thermodynamics and the kinetics. That's a single one. This one? Yeah, this one. So we discussed up to we even discussed these things, right? We wrote the examples. Yeah. Did we do the this one? What is? We discussed this as well, right? The examples plus Q's plus work done plus minus energy discuss karenge. Right. So we have to discuss the exercise, right? Right. So starting from here, from the exercise 1, right? Now, the exercise 1 it says characteristic of an isolated system is. Now you already know what an isolated system is, right? So what is an isolated system and what are the main major features in the isolated system? So the systems are divided depending on the exchange of matter and energy. So depending on the exchange of matter and energy, there are 3 systems and one of the system is isolated system. So like what is the difference of the isolated system in exchange of energy and matter? None of the energy or matter cannot be exchanged in between the system and the environment, right? So exchange of energy and matter with the environment, does it happen? No, right? It doesn't happen. This is no. Only energy is exchanged with the environment. What do you say? No. None of the energy or matter is exchanged. Only matter is exchanged with the environment. Wrong. Includes the entire universe. System is something that we observe and examine about, right? So that's So other than the system, everything is universe. Not everything is universe. Is the surrounding, and the system and the surrounding together is the universe. So this is wrong. No exchange of both energy and matter with the environment. That is correct. So the answer is 5. Nice. Answer is 5. Right. Come to the second question. Hands up those who got the question correct. Only the back row is there. Correct. What happens here, Hasa? Huh? No idea. I didn't do it. That's too bad. Malshi, you answered it? They don't like. Have you received the tubes yet? Huh? Then tubes. I will learn there. Malshi, have you received the tubes yet? Malshi, have you received the tube yet? I think they have sent it on Friday. I haven't received it. I think Viraj is sending by himself. I'll have to do it. Let's see. Huh? Oh. But bear for a few days. I will definitely do something about that. Because otherwise, I'll have to send it by myself. Yeah, I'll do definitely something about it. I'm taking the responsibility. So, bear for a few days, I'll arrange something to send. At least speed day khari api speed day avana puluwan. Flash. Courier tama matane courier the post ka tama ar tapal ki avulu tiyene kinda Right, come to the second question. Which of the following is correct regarding an exothermic reaction? So, if it is an exothermic reaction, energy is releasing, right? The heat is releasing. And like if we compare the energy of the reactants and the products, the reactants has a greater energy than the products. And what else is there about the exothermic reaction? It releases the energy, the reactant has more energy than the products, and the heat of reaction is a minus value. Yeah, the heat of reaction is a minus value if it is an exothermic reaction. So those factors you are supposed to know by now. The energy of the reactant is greater than the energy of the product. What do you say? The energy of the reactant is greater than the energy of the products. That is correct. That is correct. So they are asking correct one. So the first one is correct. We will check the other ones as well. The energy of the reactant is less than the energy of the product. That is wrong. The energy of the reactants is equal to the energy of the product. That is also wrong. The activation energy is less than the energy of the reaction. That is also wrong. Do you understand this part? The activation energy is less than the energy of the reactants. Activation energy is always more than the reactants and the products. That is somewhere on the top because it's a jump, right? If you remember the graph, it's always a jump. So it's the highest energy. The activation energy is less than the energy of the reactant. That is also wrong, right? So the answer is 1. For the second question, the answer is 1. Right. Come to the third question 3. Which statement is correct regarding the thermodynamic system and processes? Right. Which statement is correct regarding the thermodynamic systems and processes? Right. Every known process is exothermic. Every known process is exothermic. Is it? Is it? No, right? Like all sort of the reactions are there. So it's not wrong. The boundary of the system should be visible to the eye. What do you say? Huh? Visible or not? Boundary of the system, should it be visible all the time? No. But if it is a ghost, right? No. Like different systems are there that the boundary is not that visible, right? Because you can define the margin. That's the thing. You can define it. You don't see a margin there. That is wrong. Every real system is a closed system. No, mostly most of the systems are the open systems. So no, the total energy of an isolated system can vary, can it? If it is isolated, none of the energy of matter is exchanged, so it can't vary, right? Yeah, should have to be same. Fifth one, a temperature gradient can cause heat flow. That is true. That is how actually the heat flow occurs, right? When there is a temperature difference, the heat flow occurs. So the answer is 5. Yeah. We'll have to take it into 2 parts, ne? Otherwise අපිට session දෙකකට කඩලා ගන්න තිබ්බේ. Record indicates. doesn't matter for now. හරි දැන් අරකට දාලා ගන්න වෙන. ඒකට ඒක export කරන්න ගියාම වෙලා යනවා. Right. Question number 4. Which of the following is closest example for a monolithic system which is an isolated system? Monolithic system is an isolated system, right? Monolithic means isolated. So what is the closest example for a monolithic system? Is not a pressure cooker. Pressure has to release in a pressure cooker. Thermo, yeah, it's not fish tank, not light bulb, not natural reservoir. So it's hot water bottle, supposed to be a thermo flask, right? Supposed to be a thermo flask. Shanal is online back again now. Shanal, welcome. I had accident. Congratulate me now. Right, so starting from the 5th question, which of the following reaction is not an exothermic reaction? Not an exothermic. Gasoline combustion? It's definitely exothermic, has to be. Adding urea to water? What do you say? Huh? Yeah. So it's a endothermic reaction, so the answer is supposed to be this. So we don't have to discuss the rest, right? Adding piece of sodium to water, mixing potassium, yeah. No. Right. 6. A system increases its internal energy by 80 joules while doing work on it by 50 joules. Find the heat change in the system. So for these questions, I think I have given a space there, like, yeah, here. You have to do the questions there, right? So the 6th question, which equation should you apply there? What is the equation you should apply there? What does the 6th question say? A system increases its internal energy by 80 joules while doing work on it by 50 joules. Find the heat change in the system. So there's work, there's heat, and the internal energy is there. So what is the equation? Delta E equals delta QW, sorry, delta Q plus delta W should be the equation. That is delta E equals delta Q plus delta W, right? Supposed to be the equation, right? So you have to apply the values now. A system increases its internal energy by 80 joules. So the increase or the difference of internal energy is how much? 80 joules, right? That is equal to while doing work on it by 50 joules. So the while doing work on it means that the work is done on the system, which means plus or minus. The energy is adding to the system, right? That's a plus. So the 50 joule is a W, that is plus, and they are asking to find the heat change in the system. So now we don't know the delta Q, that is what they are asking for, and the delta W is a plus 50 joule. So how much is the delta Q now? Delta Q should be equal to 80 minus 50 joules, that is 30 joules, isn't it? Answer is 30 joules, right? Take a note. Finish? Right. So come to the 7th question. A woman performs 500 joule of work and releases 9500 of heat into the environment, right? Like this is usually happens if you have a lot of fat. Why? The majority of the energy when you are doing a work goes to burn the fat. It's like the friction in a system, like the fat in a person's body is like the friction in a machine. Why? When you are fat, much of the energy goes to burn the fat. That is why usually the fat people, you know, can't be more like they don't work really powerful. You know, they have the energy, but majority of the energy is like wasted to dissolve the fat or to burn the fat, you know. That is what usually happens. So usually the majority of the energy is going to burn the fat. That is why they can't work much. So definitely a fat woman, right? I'm like not trying to be no, yeah. So that is what has happened, because like 9500 joules of a 9500 joules of heat and only 500 joules of work. That's a very small work compared, right? Much of energy is wasted on the fat, yeah, or the friction in a machine, right? So how much does her internal energy decrease and her efficiency? Definitely the efficiency is less, because they are only doing a 500 of a work, wasting 9500 of energy. So yeah, not much efficient when you are fat, so don't be fat. Chubby is a different case. It's a different case. We are talking about the fats, right? No good, like no big amount of fat is acceptable. So the 7th question, the same equation should be applied. What is the equation now? Delta E equals delta QW, sorry, delta Q plus delta W. So the first question is asking to find the internal energy, isn't it? How much does her internal energy decrease? So now the heat release is 9500 joules, that is released to the environment, that is a minus value, right? And the work done is also done to the environment, that is also a minus value. So the energy lost from the internal energy is 9500 and 500 of joules, that is minus 10,000 of joules, right? That's huge amount of energy lost. Yes. So now that is the first question. Second one is asking find the efficiency. Now what do you call the efficiency? Yeah. So the work output over, yeah. So the either the work output or the power output over the energy consumed into 100%, right? So now tell me the work output there. How much of a work has done? That is only 500 of a work. That is only 500 joules of a work done. And how much of a energy? 10,000 directly. Yeah? It's 10,000 directly, like the whole energy is 10,000. So now altogether 10,000 has consumed. And the efficiency is this into 100%, right? This is the work done and this is the energy consumed, and that into 100% give the efficiency. So how much of efficiency is there? That is only 5%, right? So the efficiency is 5%, not enough, right? Not very efficient. Output take 500 joules. ඒ කියන්නේ output එක කියන්නේ the machine එක ගන්න machine එකක output එක කියන්නේ එයා කරන වැඩි. So if you are a machine ඔයාගේ කරන වැඩේ තමයි ඔයාගේ output එක. Input එක කියන්නේ ඔයාට දෙන energy එක. So it's a how much? 5% of a work, right? It's a 5% of a work. Right. So the next question, 8th question. A system does 4.8 joules of a work on its surrounding and releases 18.4 joules of heat energy. Find the delta E. So the both releases to the surrounding, isn't it? So both are minus values, right? So if I apply the equation delta E equals delta Q plus delta W, that will be delta Q is how much? Delta Q is 18.4, right? That is 18.4 joules. That is a minus, and minus the work done is 4.8, and that is also minus, so it's 4.8. Adding these two together, how much of a value? That is 23.2. 23.2 joules of a value has like lost from the internal energy. Me energy lost internal energy. That is why the minus is there. Internal energy reduced right. So people are coming and going. No signal issues around. So question number 9. When a work of 150 joule is done on the system by the surrounding environment, the value of delta E of the system becomes 100 joules. The heat energy change that must occur in the system is, right? When a work of 150 joule is done on the system by surrounding environment. So work of 150 joule is done on the system. So is it plus or minus? The work is done on the system, so that's a plus. By the surrounding environment, the value of delta E of the system becomes 100 joules. Now the value of the internal energy is now 100 joules, right? This is 100 joule, that is the internal energy. The heat energy change that must occur in the system is, right? So, you have to apply the same equation back again. That is delta E equals delta Q plus delta W, and it says what? 150 joule is done on the system by the surrounding. So, this is 150 joules and it's a plus, and it says the value of delta E of the system becomes 100 joules. Now, the delta E is 100 joules. So, they are asking for delta Q, right. So, delta Q should equal to 100 minus 150, that is minus 50 joules, right, that is minus 50 joules. Yeah. So, these are easy, right. Yeah. So, the calculation somewhat in this up to this part is easy. Yeah. Yeah. So, the moles are there in the other questions. You know, the standard heat of equation, you have to know the how to take the moles of any sort of a molecule, reactant. You have to know how to take the moles, number of moles. That is one thing. That is a bit of a knowledge from O levels. But now it's easy, because when it comes to the A levels, it's easy because you just only have to apply the equation N equals M over M. That's all. Nothing more than that. You just don't have to. Yeah. Because like when it comes to the moles, there's a bit of a different understanding what mole actually is. But we don't care now, right? You don't have to know how and what the moles is. But I have given you the data in the tube. Just refer it. But it's okay you don't understand it, because we don't need it. That is only for the further understanding, that's all, right. You just only have to know these two equations. One is N equals M over M. That is how you take the number of moles. If the mass of the molecule or any of the substance is given and the molar masses are given, you are supposed to know how to take the number of moles. The other one is C equals N over V. That is also one of the equations from the O levels. Yeah. So, that is how you take the concentration. Yes. So, C is the concentration, N is number of moles, V is the volume, that is in cubic decimeters. Yeah, cubic decimeters. So, you are supposed to know all that knowledge, but you don't have to, but because like molar mass එකට ගොඩක් වෙලාවට අර මේ එක දෙනවා මොනවාද ඒ කියන්නේ atoms වල molar masses ටික දෙනවා. එතකොට ඔය molecule එකේ molar mass එක atoms වල molar mass එකතු කරලා ගන්නවා. හරි. හරි. අර relative mass ඒ කියන්නේ molar mass කියන්නේ relative mass කියන්නේ දෙකම එකයි. හොඳයි. සමහර කාට molar mass එක විදිහට කියනවා, නැත්නම් relative mass කියන්නේ ඒකම තමයි. Right. So, we discussed this part as far as I remember, the law of conservation of energy. What does the law of conservation of energy means? It's something about the system surrounding and the universe. We discussed that if you take the both system and the surrounding together, that is the universe, because what we say a system is anything that we take to examine or to that we focus on, right. So, apart from that system, everything else is what? Is the environment, right. Everything else is environment, which means like literally means everything, right. Everything means literally everything, space and everything are the everything, the surrounding becomes the surrounding. Now, if I take this pen as the system, except for this pen, everything is surrounding. That means all the mass and all the nebulas and everything are the surrounding, right. So, everything are surrounding, right. So, except for the system, everything are the surrounding. So, the surrounding and the system together becomes what? Yeah, becomes everything, means yeah, everything is the universe. Yeah, everything makes the universe, because the system is the one thing in the space that we examine, and everything except for the system is the surrounding. So, everything except for the system. So, that one thing is missing, what? the system is missing. So when you add that to the everything, sorry, when you add the system to the surrounding becomes everything, because you know, everything except for the system is the surrounding. When you add the system, it becomes everything. Everything means simply means the universe, right? It means the universe. Yeah. So now that is not the thing that even we discussed this part as well. The important thing is this. So a 10 joule of energy is, let's say a 10 joule of the energy is released from the system, which means it becomes minus to the system or plus to the system. Energy is released, 10 joules becomes minus to the system, 10 joules is minus to the system. And when it's minus to the system, which means if we take it in the perspection of the environment, it is adding to the it is getting plus. Yeah? So it's a plus joule to the plus 10 joule to the environment, right? So now this is the energy exchange or the energy difference of the system. 10 joule was deducted. This is the energy exchange or the energy difference of the surrounding. 10 joules were added. Now what about the energy difference of the universe now? Becomes 0, because universe is energy difference of the system plus energy difference of the, so the plus 10 minus 10 becomes 0, and that is the conservation of energy. What does the conservation of energy say? The energy of the universe is a constant. It doesn't increase or decrease. There is like, how do they say it? They say it, the energy cannot be created or destroyed, which means it won't become more than the energy that it has or less than the energy that it has, right? And the energy only transfers from one kind to another. That is what only happens, right? So the energy difference means the energy either has to increase a little bit or to decrease a little bit, right? It does like that. This 0 doesn't mean the energy is 0, right? It has a constant value. We don't know it. We haven't ever calculated it. We can't anyways. There is a certain value. Let's say it's 100 joule. So it won't become 101 ever. It won't become 99 ever. That is what it says. The energy difference is 0, right? Energy difference is 0. Won't reduce, won't increase, right? You understand that one? Yes, good. So the difference of energy is 0, and there will be like, there was a question on this part, you know, in the past papers. There was a question, values there, they are asking the energy difference of the universe. So the energy, like the energy of the universe, it doesn't change, so it's 0. Yeah, there's nothing to calculate there. This is, if you are to calculate, this is how you calculate it, right? Standard heat of reaction. Now this is very, very important. So standard heat of reaction is like, if we take a reaction, like the heat of reaction will change depending on many things, you know. So if I take a reaction, let's say a HCl and NaOH reaction, HCl reacts with NaOH and it releases energy, right? I'll come to the board. The circle is here, right? Let's say HCl and NaOH are reacting together, right? HCl and NaOH are reacting together. Now I can watch the recording back how Ravishka was teaching. Huh? You taught them good? He taught you good? This guy? Did he taught you good? Yeah? That's why I was asking. It's fine, right? Good thing. Right. So HCl, bro, what happened? So Ravishka is one of the fast track students, and he's 2026. He's supposed to do the exams in 2026, but doing it in 2025. So it's somewhat a good case, yeah. Right. So let's say the HCl plus NaOH means the HCl acid, NaOH base are reacting together and it forms NaCl, sodium chloride, you know. So the H2O is another product and usually the energy or the heat is released, right? The heat is released, energy is released. So this is an exothermic reaction. But now this is the thing. Now in this reaction, the energy release will depend on so many things, will change on so many things. That is the point. This energy release will change on so many things. If some factors change, the energy release will also change, you know. Let's say if I take 1 mole by each, the energy release is a certain amount. Let's say I am taking like 1 mole of this and 1 mole of this. It means a certain amount, a mass, let's say, certain mass is taken. So the energy release will be, let's say, 10 joules. But if I take 2 by 2, 2 moles and 2 moles, now the energy release will be 20 joules. It changed, right? So it's a different value now. And if I change the pressure, if I change the temperature, the heat that is releasing will be different, right? So we can't take different values into consideration when it comes to the research and calculations, you know. We have to come for a exact value for the ease of calculation. Do you understand that? For the ease of calculation, we have to come for a certain frame or a certain standard, we call it. That is why you call the standard heat of reaction, which means we specify the conditions. Get it? We specify the conditions. So under that condition, the standard heat of reaction must be a constant value. So if we say the standard heat of reaction of HCl and NaOH reacting, that is a certain exact value. It doesn't change, you know, it doesn't change like this, because it is given under a certain frame or under a certain standard, under the certain conditions. Yeah. So it is the energy release under a constant temperature and a constant pressure, and the heat release is calculated for per mole, right? The heat release is calculated per mole, right? So it is under a certain temperature, it is under a certain pressure, and the energy release is calculated only per mole. Get it? So the energy release is given kilojoules per mole. Get it? The energy release is given kilojoules per mole, right? So in this case, now this is 1 mole reacting and this is also 1 mole, and 10 joules is produced, right? 10 joules is produced. And if this happen under a constant pressure, a standard pressure, which is 1 atm usually, 1 atm, and a constant temperature, which is usually 25 degrees of Celsius, right? And under those conditions, if the release energy was 10 joules, the standard heat of reaction of HCl and NaOH should be how much? 10 joules. It is not, but what I'm telling is, like, if it was, it should be 10 joules. So that will become the standard heat of reaction. So if I do this reaction under constant pressure, under the constant temperature, and if I only reacted 1 mole of this, the heat release is the standard heat of this complete reaction, right? Get it? Right. So if you have to calculate the standard heat of reaction, you don't have to worry about the temperature and the pressure, because it is nothing that we have to consider about. But the only thing what you have to consider about is number of moles. You know, in your calculations, you don't have to consider the temperature or the pressure. It's not varying in your questions. But this the amount, the number of moles is definitely changing. So if you want to find the standard heat of reaction, you will need always to take the energy release per mole, right? You have to take the energy release per mole. So sometimes they are giving this much of a this much number of moles are reacting. Let's say 10 moles of this is HCl is reacting, and this much of energy is released. Let's say 10 mole of HCl is reacting and 100 joules of energy is released, and they are asking for the standard heat of reaction. So how much should be the standard heat of reaction? That should be per 10 moles 100 joules. You have to find it for 1 mole. So if it is for 10 moles 100 joules means 1 mole, how much? 10 joules. So how do you take it? You divide the energy by the number of moles. It is simple as that, right? So that's the equation actually. So this is the equation. See, delta H naught, the standard heat of reaction, is equal to Q. What is Q? The energy released, and N, the number of moles reacted. That's all, right? It's simple as that. It's very simple, right? And these few things you're supposed to know. The Q should be always in kilojoules, right? The energy release, you don't apply it in joules. You have to remember that. So most of the people, when it comes to structure disease, sometimes the 20-25 students as well, they put it in joules. They forget that they're supposed to put it in kilojoules. That's a mistake. I don't do that. So you divide the number of joules by 1000, that is kilojoules, right? You divide the number of joules by 1000, that's kilojoules, right? So you have to apply it in kilojoules, and number of moles, that is moles, right? So you get the answer kilojoules per moles in unit. Get it? Right. So now these are the when it comes to the questions, bit of a tricky parts are there, right? Bit of the tricky parts, one of the tricky part is to find the number of moles, right? So there are two ways to find the number of moles, as we discussed. The one of the equation is N equals M over M. That is N equals M over M. What do you mean by this equation? N means number of moles, and M, simple M, is the mass. Capital M is the molar mass, right? Capital M is the molar mass, right? So that is one of the equation to find the number of moles. And there is another equation, C equals N over V. In this case, C means concentration, N means number of moles, and V means volume. Get it? V means volume, right? So concentration, number of moles, volume, right? So using these two equations, you can find the number of moles, right? You can find the number of moles easy. Get it? Nice. So come to this question. 80 gram of CH4 were burned with excess oxygen, right? Calculate the standard heat of reaction. So how do you calculate the standard rate of reaction? Delta H naught equals Q over N. This is the equation. Delta H naught equals Q over N. So do you have the Q? Q is supposed to be given, yes. It's not given? The energy release supposed to be given, right? Let's say CH4. අපි එක standard value එකක්ම ගමු නිකන් guess කරලා value එකක් දාන්න නැතුව. මෙන්න standard heat of combustion of CH4 value එක බලමු. minus 890. Minus 890. So that is minus 890. Okay, 12, 16. Right, minus 445, right? minus 445,000 joules. Take it this way. The energy release is this much, right? Energy release is this much. So you have to calculate what? The standard heat of reaction. Now can you apply the values and make a energy release with එක exothermic reaction. True. Right? I'll do it, right? So you have to apply the values now. What is Q? Q should be the energy release or the heat in what units? Kilojoules. Is this in kilojoules? No. What do you have to do? You have to divide by 1000 and apply the value. What is the value when you divide it by 1000? 445 kilojoules. You have to apply it in kilojoules. Divide by the number of moles, the next thing, right? So I have given you this space to calculate the number of moles. So what is the equation you apply here to find the number of moles? N equals M over M, right? N equals M over M. Now the M is the mass, that is 8 grams. That is 8 grams. Then the capital M is the molar mass. Back again you have to calculate it. So how do you calculate the molar mass? You have given the relative masses. Yeah, carbon is 12, hydrogen is 1. So you have to calculate the molar mass of CH4. So how do you calculate it? Carbon is 12 and only one carbon is there. 12 into 1 plus how many hydrogens are there? 4, and one hydrogen molar mass is 1. So it's 1 into 4. Adding them together you have 16 grams per mole. Yes, it's 16 grams per mole. Yes, 16 grams per mole. So you divide this by 16 gram per mole. Yeah. So what is the answer you get? Number of moles are 0.5 moles. So you have the N now. Now you can apply it here. Yes. So you have to go step by step. Have to remember the steps and do the calculation. So we had to find the number of moles. To find the number of moles, we had to calculate the molar mass of the CH4, and you had to apply the number of the joules in kilojoules. Yeah. So all that things you have to remember, because if you missed any of the points, you are losing the marks. So now this is 0.5 moles. Yes. So you divide it by 0.5, you get how much? 890 kilojoules per mole. Yes. This is the standard heat of combustion of what? Methane. This is the standard heat of combustion of methane. That's easy, right? Minus 980 kilojoules per mole. Yes. Now did you understand this part? Yeah. Got it? Good. So because like අර ළඟ පොඩි පොඩිව වෙනස් කරනවා හොඳ. එතකොට you have to have the whole knowledge to go on the process and get into the answer, right? Right. Fine. Yeah. තියෙනවා බලන්න. Questions are there, don't worry. I'll give you then let's go on the process. The questions are there, don't worry. Me example questions තියෙනවා. Step by step තියෙනවා ඔක්කොම ටික මේ ටික තියෙනවා මීට වඩා අමාරු ඒවා තියෙනවා බය වෙන්න එපා. Questions මදි වෙන්නේ. හරිද? උන්තරන්නේ question bank එකම වෙනම තියෙනවා ඊට පස්සේ. Don't worry about those, right? Come to the next one. Now you understand this part, right? Yeah. So this is another thing, this is also important. When the above reaction is performed in the opposite direction, or when the direction of the reaction is changed, only the mark of the heat of reaction change, right? The value does not, which means like the reaction that occurs here, the combustion of methane with oxygen, that is this, right? CH4 plus O2 produces carbon dioxide plus H2O plus the energy, right? This is the energy release, right? And we have to balance this equation. So when you are balancing a hydrocarbon combusted with oxygen, for all the hydrocarbons combusting with oxygen, this is how you balance, right? First you balance the carbon. How much of a number of carbon there? 1 here. So 1 here as well, so it's balanced already. First thing you balance the carbon. Next you balance the hydrogen. So 4 hydrogens are there, only 2 hydrogens are here. So you have to even those. How do you even it? You have to put a 2 in the front here. So it's 2 into H2O, like 2 H2Os are there. So in 2 H2O, 4 of the hydrogens are there, 2 of the oxygens are there. So only we had to even the hydrogens now. So 4 hydrogens are there, 4 hydrogens are here. So it's balanced here. What is the next thing? You finally balance the oxygen, right? That is the final to balance. So oxygen here, there's 4 here, sorry, there's 2 here, there's 2 here. So altogether 4 are there, here only 2. So how do you balance it? So you have to apply a 2 here, that is 4. Good, nice. So this is the balance equation, and the energy release in this reaction is 900 and how much? How much did you calculate? Sorry, 890 kilojoules per mole is the standard heat of reaction, right? And if I reverse this reaction, what is the reverse of this one? So if you have to reverse this reaction, which means carbon dioxide and H2O are reacting to produce methane and oxygen. If you reverse this reaction, only this minus will change, right? The mark will change, only the mark will change, but the value should be same. Yeah, for a reaction to reverse, the mark will change. So what does what does it mean, like the mark will change? It means the reverse reaction is a endothermic or exothermic. The reverse reaction is a endothermic. So if it is a exothermic reaction, the forward reaction, the reverse reaction always should be, if the forward reaction is exothermic, the reverse reaction always should be endothermic. If the forward reaction is a minus, the reverse reaction is always a plus. Get it? That is what it says. And the value doesn't change because it's the same reaction reverse. The value doesn't change, only the mark change. Mark means the minus or plus. In this case, it was a minus, the reverse of it should be a plus, but the value is same because it's the same reaction reverse. Yeah, same reaction reverse gives the same energy, or like it takes the same energy going back. Also because it's taking the energy, it's a absorbance, so it's a endothermic reaction, and the value is same, only the mark is different. Yeah, that's all. Right. The change of state of matter, right? What's the time? I have 10 minutes to go. We can do more, right? We'll do a calculation. We'll come to a calculation. Oh, make a limiting factor consider කරලා ඔව් මේක limiting factor එක consider කරලා මේක චුට්ටක් අමාරු වෙනවා ඒකෙන්ද limiting factor එක consider කරලා තියෙන හින්දා අපි මුලින් මේ වගේ එකකුත් හදලා ඊට පස්සේ යමු එතනට මේක හදන්න බලන්න first question exercise 2 first question of the exercise 2 amount of heat released during the combustion of 14 grams of ethylene gas was minus 604 kilojoules. The molecular mass of C2H4 is 28 grams per mole. The balance reaction for the given is shown below. Right. They are asking the maximum energy released by burning 1 gram of CH4. नहीं මේක තමයි question එක.
amount of heat released during the combustion of
sorry. ඒක continue වෙලා නැහැ question එක නේ. ඒක අහන්නේ standard heat of reaction. The amount of heat released during the combustion is දීලා තියෙනවානේ. මෙච්චරයි කියලා. So they are asking for the yeah. So find delta H naught should be the question. Oh. Find delta H naught of this reaction. Find delta H naught of this reaction. So you're supposed to find the standard heat of reaction. Finish? Found any answers? 3, good. Shinal, nice. 3, is it 3? Oh? තුන්දයි? මට මත පහ වගේ. Shinal, good. Malshi. මතකද ඒක? උත්තරේ. දැන් නේද? back row. Third one there. නෑ නෑ මගේ මට මතක මම මේ වෙනස් කරනවා සමහර කාලේ වැලියුස් වෙනස් කරනවා සමහර වැලියුස් මතකයි
අපිට මොකද ඉන්නේ සර් කියලා දුන්නා.
ඔව් ඔව් මේ ටික තිබ්බේ හරිද right so they are asking for the standard heat of reaction. Now tell me the values So we have to find delta H naught, and that is Q over N. And how much is the Q given? Minus 604 kilojoules, and that is for 14 grams. We have to find number of moles of that, right? 604. 604 kilojoules, right? And we have to find the number of moles. So now how do you find the number of moles? N equals m over m. The mass of CH4 is given as 14 grams and the molar mass is given 28 grams per mole. So this cancels out this half moles, right? Half moles means 0.5. So you have to divide this by 0.5 or half. The answer is double of this, right? So that is 1208 kilojoules per mole. Easy. Yes? Yeah, answer is 3. So you can try all these questions at home. And the concentration question we will discuss. You try it at home. Oh, try all the questions. දෙවෙනි එකට කීයද? So try the second question. Shinal, correct. The answer 3, yes. Malsi, did you answer it? The previous one. So the back row, you answered it. The previous question. Yeah, get the answer. Good. Very good. Now try this one. Answered it? Why are you wearing a mask now? Becoming a ninja or becoming a sick person? Moon on. To hide the beauty. ඒ නිදිමන් හින්දා වෙන්නේ. මේ දවස්වල නම් ලෙඩ වෙන්න එපා. මේ දවස්වල ලෙඩ වෙනවා කියන්නේ. ජීන්ස් වලින් එන තාත්තට අම්මට තියෙනවා. ඇලර්ජි එකක් ඇති සමහරට. Right. You found the answer for the second question as well? Huh? Huh? 15,000 ගානක් වගේ ආවා. Is that in joules? No, even 15,000 આવત මේක එන්න බෑ. So you finally have to find Q. 60. 60 is the answer. Anyone online? No, Malsi didn't answer any of that. Now where was Shiny there? Shiny wasn't there? Uday nam diya neda? Tuna. මේක 3 නෑනේ. Yes. Numbers repeat වෙලා කියන්නේ. Number කරන එක repeat වෙලා. Right. So how do you apply this? So you have to apply the delta H naught equals Q over N equation. Right. Delta H naught equals Q over N. So this is supposed to be the equation delta H naught equals Q over N. So the energy released, you have to find the energy released, right? And the delta H naught is given. How much is the delta H naught? Delta H naught is 960 kilojoules per mole. Right? It is minus 960 kilojoules per mole. So you have to find Q and you have to find the number of moles. So they are asking the combustion of 1 gram of methane, right? So now the equation is supposed to apply is N equals M over M to find the number of moles. So now methane is how much? We found it already. Methane CH4 is 12 into 1 plus 1 into 4 together, that is 16 grams per mole. So N should equal to 1 over 16 grams. So that is 1 over 16. So you have to apply, I will apply the same way, like 1 over 16, right, is the number of moles. So if you cross multiply it, you can get the energy release, which is Q. So that is Q equals 960 multiplied by 1 over 16, which means 960 divided by 16. 960 divided by 16 is how much? How much? 60. Is it? ඒක මම directly fraction එක විදිහට මරන් ගියේ. කියන්නේ මේ division එකට තියෙන මේ complete fraction එකනේ. නෑ reciprocal වෙන්නේ. Complete fraction එක මම අරන් ගියා එහා පැත්තට. How much? 60. Right. So the answer is 60. Answer is 3. Answer is 3. Shinal correct. 3. Right. So we'll finish for today now. Sorry for the inconvenience. Bear myself for a few weeks because I'll be traveling with the public transport for a few weeks and will be having some of the difficulties finding the time to come for a class. Oh, a bit of issues are there, so I'll try to do my best. And thank you, Ravishka, for taking over the class in the morning. It's a bright case. but you have some sort of name konjum out of the tracks යනවා සමහර වෙලාවට ඒ ටික හදාගත්තාම පස්සේ a very bright trace, right? So guys, I'll see you on next week. Then it's ciao. Can somebody ඉරත් සඳන්නේ සඳන්නේ හරි යන්න බෑ.